Continuing the idea of conditional probability, we're just going to look at some more examples using Venn diagrams. Now, in the last video I showed you that when we're talking about the probability of B given that A has occurred, what we mean is we are only interested in this A circle here. We are imagining that all of this has gone, that doesn't exist anymore, this bit doesn't exist anymore. We've restricted our sample space only to this circle here. So the best way to talk about this is to give you an example. We're not giving any context to this question, just some events with probabilities. So the probability that A occurs is 0.55, B 0.4, and the intersection of the two is 0.15. Now, whenever we populate a Venn diagram, we start from the intersection, so 0.15, which means here we are going to work out the probability of just A without B. So that's going to be 0.55 minus 0.15, so 0.4. And then here, the probability of B was 0.4, so subtract 0.15 from that to give us 0.25. Now, if we add all of these up, we've got 0.65, 0.8, which means outside here in the probability of neither of them occurring is going to be 0.2, because of course all of it has to add up to 1. So let's think about reducing our sample spaces to answer these conditional probability questions. The probability of A given that B has occurred. Now I'm going to run out of space if I try and shade this. So I'm just going to do a rough copy here without the numbers to show you what we're restricting to. A and B. So given that B has occurred means that I'm only interested in the B circle. So I'm going to get rid of all of that. All that's gone, and get rid of this bit. So I'm only interested in that bit there. So within that circle, what's the probability of A happening? Well, A only occurs in the intersection there now. So we're interested in 0.15 out of the probability of B occurring, which was 0.4. So let's work that out as a simplified fraction. 0.15 out of 0.4 is 3/8. Now let's do it for this one. Same idea, slightly more complicated in terms of the Venn diagram, but the Venn diagram is definitely the best way to think about this. So what are we restricting our sample space to here? It's always the given that. What's the probability of B occurring given that A or B has occurred? So we restrict our sample space to A or B. The union of A and B is the circles. So we get rid of the bit on the outside. We're only interested in the circles, which means we're out of 0.8 because that was the probability of A or B. So within that, what's the probability of B occurring? Well, that's the B circle here, which would be 0.4 because the probability of B is given at the top. So that simplifies to 1/2. And then for the third one, what's the probability of A not happening given that B has also not happened? So let's think about our diagram. And what are we restricting the sample space to? We're restricting the sample space to B not happening. So we need to be outside of B. So we are interested in this section of the A circle and the outside of both circles because that's B not happening. So the bit we want to eliminate is that bit there, that bit's gone. So within this area that's left, we're interested in the probability of A not happening. So first of all, let's put as our denominator the entirety of the sample space. So this little section here was, the whole of the A circle even was 0.55. I've made a mistake, ignore me. If B is not happening, we don't want that bit either because we've got to be completely outside of B. So try again. This bit here was 0.4 and the bit outside both of them was 0.2. So 0.4 add 0.2 is 0.6. And then what's the probability within that of A not happening? So we've got to be outside of A now. Outside of A is this area around the outside of the circles, which has a probability of 0.2. So we're dealing with 0.2 out of 0.6, which is 2/6 or 1/3. Okay, have a go at exercise 2C.